ಅಲ್ಲ ಸರ್.
ಓಕೆ ಸರ್, ಓಕೆ.
ಶುರು ಮಾಡೋಣ ಸರ್.
ಆಗ್ಬೋದು ಸರ್.
ಗುಡ್ ಈವ್ನಿಂಗ್ ಎವ್ರಿಬಡಿ. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಇವತ್ತಿನ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮ ಮಾಲೆಯಲ್ಲಿ ಡಾಕ್ಟರ್ ಕೆ.ಎಸ್. ಲೋಕೇಶ್ ಅವರು ಸ್ಟಾಕಿಯೋ ಕೆಮಿಸ್ಟ್ರಿ ಮೇಲೆ ಉಪನ್ಯಾಸವನ್ನು ಕೊಡಲಿದ್ದಾರೆ. ಸೊ ಡಾಕ್ಟರ್ ಕೆ.ಎಸ್. ಲೋಕೇಶ್ ಸರ್ ಬಗ್ಗೆ ಒಂದು ಕಿರುನೋಟ. ಒಂದು 2 ನಿಮಿಷ ತಮ್ಮ ಬಗ್ಗೆ ಒಂದು ಇಂಟ್ರೊಡಕ್ಷನ್ ಕೊಡ್ತೀನಿ ಸರ್.
ಆಗ್ಬೋದು ಆದಷ್ಟು ಕಡಿಮೆ.
Lokesh is presently working as professor in chemistry at Vijayanagara Sri Krishnadevaraya University, Bellary from 2012. He obtained his master's degree in chemistry and a PhD degree from Mysore University, Mysore. Then he worked as postdoctoral fellow at University Joseph Fourier, France from 2009 and University of Gent, Belgium in 2010. Then he worked as assistant professor at Shinshu University, Japan from 2010 to 2012. His research interest includes isoindoles and profane or phytocyanamine based microcycles for biological and electrochemical applications like sensing and clean fuel production and energy storage devices. And also, he teaches analytical and material chemistry to master's degree students. He has received research funding from DST, CSIR, and VGST of worth more than 2 crores. He has been awarded Uzbekistan Joint Research Project on clean energy production. He has published more than 85 research publications in international journals, 2 book chapters, and 1 Indian patent to his biological applications. He has guided 8 students for PhD degree. 2 students have submitted their thesis, and 4 more are working. He has received awards like Sir C.V. Raman Young Scientist Award, Best Publications Award from Government of Karnataka. He was awarded TWS Research Fellowship for working in China. He has served at various administrative responsibilities in the university like Chairman of Chemistry Department, Dean of Faculty of Science, Academic Councils and Syndicate member of VSK University, and also as a NAC peer review committee member. As part of his research work, he has visited France, Belgium, Italy, USA, Japan, and China. Okay, sir. Thank you. Over to you, sir.
Thank you, Sujagowda sir. Thank you very much for introducing me. And also, I thank you as well as KSTA for inviting me to deliver this lecture on stoichiometry for the students across Karnataka. So, today I am giving lecture on stoichiometry and stoichiometric calculations. So, my talk involves introduction, balancing of chemical reactions, limiting reagent, and the reactions in solution. So what is stoichiometry? The word stoichiometry is derived from 2 Greek words, which means that element. Stoichion means element and metron means measure. So in overall, stoichiometry means the measure of elements. Stoichiometry is usually deals with the quantitative study of the relationship between the reactants on left hand side and the products formed on the right hand side of a chemical reaction equation. So you can have the stoichiometry based on moles, masses of the substances, molecules, and volumes. So any chemical reaction involves the reactants and the conversion of reactants to form products. So here, reactants are the substances which undergo chemical change in the reaction, and the products are the new substances that are formed from the chemical reactants, the reactants. So therefore, a chemical reaction takes place when the reactants undergo chemical change by reacting with one another to form a new product, that is a chemical reaction. The reaction between reactants to give a new product is called as chemical reaction. So when we write the chemical reaction, we use symbols, chemical symbols. So chemical reactions are generally written in the form of equation using chemical symbols. For example, we write for carbon as C, oxygen as O, hydrogen as H, nitrogen as N, etc. So the reactants normally in the chemical equation, the reactants are written on the left hand side and the newly formed products are written on the right hand side. And the chemical reactants are separated from the products using a arrow. The arrow, if it is a single arrow, then it indicates that the reaction is irreversible in nature. That is, only reactants react to give a product. If the arrow is a double arrow or reversible arrow, then double arrow indicates that there is a formation of products as well as products are getting converted into reactants again. That means there is an equilibrium between reactants and the products. So the arrow indicates the direction of the reaction, For example, the reaction between hydrogen and oxygen giving the product water is written 2H2, where hydrogen is represented as H and oxygen is represented as O, giving product water which is represented as H2O. So in the reaction between hydrogen and oxygen to give water, hydrogen molecule and oxygen molecule are involved in the reaction, which are present on the left hand side of the reaction. They are called as reactants, and the water molecule formed is called as product. The right hand side of the equation is product, and the notations which are in the bracket, which are represented as G and L. G means it indicates that they are in gaseous state, and L indicates that means the water is in liquid state. The coefficients present on the reactant side and on the reactants as well as on the product side, the 2 on H2, 1 on O2 and 2 on H2O, that is called as coefficients. The coefficients 2 in case of hydrogen and water and 1 in case of oxygen, they are called as stoichiometric coefficients. So these stoichiometric coefficients indicates the number of molecules or moles taking part or that are formed during the chemical reaction. So what is the basic principle in stoichiometry? The basic principle of stoichiometry follows the law of conservation of mass. This law of conservation of mass, which you have studied in your lower classes, states that in a chemical reaction, mass is neither created nor destroyed. Mass is neither created nor destroyed. That is, total mass of the reactant and the product remains equal or the number of atoms of each element remains same before and after the chemical reaction. So when you have same number of atoms on both left hand side and right hand side, then the equation gets balanced. So that type of chemical reactions are called as balanced chemical reaction. For example, if you take the reaction between methane, which is having a chemical formula of CH4, it reacts with 4 chlorine molecules. 4 chlorine molecules, Cl2, that is chlorine molecule, 4 Cl2 molecules to give carbon tetrachloride plus 4 HCl, carbon tetrachloride plus 4 HCl. Here, the reactants are methane and chlorine, and the products on the right hand side are carbon tetrachloride and 4 HCl. So you have to calculate the number of atoms or atomic mass of each atom, each type of atom on reactant side and product side, and then you need to balance the same number of atoms or same number of atoms should be present on both left hand side and right hand side or on reactant side and product side. So here the element carbon is one number of carbon atom is present on the reactant side, so its atomic mass is 1 into 12. In the same way, there are 4 hydrogen atoms on the reactant side, so its atomic mass is 4 into 1 is 4. And chlorine, you have total 8 chlorine atoms. Each chlorine atom has atomic mass of 35.5, so it is 284. So the total mass of left hand side is 300, and total number of atoms on left hand side is, that is reactant side, is 13. If you take on the right hand side or product side, the number of carbon atoms is 1, so atomic weight is 12. The number of hydrogen atoms on right hand side or product side is, that is near HCl, there are 4 hydrogen, so 4. So chlorine, there are carbon tetrachloride, there are 4 chlorine in carbon tetrachloride and 4 chlorine in HCl. So there are totally 8. That means you have same number of atoms on left hand side and same number of atoms on right hand side, that is reactant side as well as product side, and also the atomic mass of each element are same on left hand side and right hand side. That is, law of conservation of mass is followed or obeyed in this chemical reaction because it is a balanced chemical reaction where you have same number of atoms on left hand side as well as right hand side. So the balanced chemical equation is an equation in which number of atoms of each element present in the reactant and the product side are same or equal. So each type of element present on left hand side should be equal to each type of element present on the right hand side. For example, if you take the reaction between calcium carbonate and HCl, then 1 mole of calcium carbonate reacts with 2 moles of hydrochloric acid to give 1 mole of calcium chloride and 1 mole of carbon dioxide and 1 mole of water. So this is in terms of moles. You have balanced chemical reaction between left hand side and right hand side or between reactants and products. The same chemical reaction can also be spelled or named as 1 molecule of calcium carbonate solid reacts with 2 molecules of hydrochloric acid which is a liquid, to give 1 molecule of calcium chloride, which is aqueous or liquid, and 1 molecule of carbon dioxide, which is a gas, and 1 molecule of water. So in terms of molecular weight, or weight of the substance, 100 gram of calcium carbonate, that is, if you add the atomic weights of all the elements present in the molecule, then you will get molecular weight. 100 gram of calcium carbonate, that is molecular weight of calcium carbonate, reacts with 73 gram of HCl. Here there are 2 molecules of HCl. Each HCl has having a molecular weight of 36.5. Since 2 molecules are there, you have 36.5 into 2, that is 73 grams, to give 111 gram of calcium chloride. Again, it is the molecular weight of calcium chloride. 18 gram of water, it is the molecular weight of water, and 44 gram of carbon dioxide, it is the molecular weight of carbon dioxide. So when you have a gaseous species, gaseous molecule, then 1 mole of gas, concerned specific gas, is equal to 22.4 liters of gas at standard temperature and pressure. At standard temperature or pressure. So when we say 44 gram of carbon dioxide, means it is equivalent to 22.4 liters volume. In terms of volume, 22.4 liters at standard temperature and pressure. So another equation, nitrogen, which is a famous Haber-Bosch process for the production of ammonia. So here on the reactant side, we have nitrogen, which is a gas, and we have hydrogen, 3 molecules of hydrogen, 1 molecule of nitrogen. They are in gaseous state. They react with each other to give a product called ammonia, 2 moles of ammonia gas. So here 1 mole of nitrogen reacts with 3 moles of hydrogen gas to give 2 moles of ammonia. So it is the equation in terms of moles. If you take the same reaction, chemical reaction, in terms of volume, then 1 mole is nothing but 22.4 liters of volume at standard temperature and pressure. So 1 mole of nitrogen is nothing but 22.4 liters of nitrogen reacts with 3 into 1 mole, that is 22.4 liters of hydrogen gas, to give 2 moles of ammonia, that is 2 into 22.4 liters of ammonia at standard temperature and pressure. Or you can also write the same reaction. You can also tell 1 ml of nitrogen reacts with 3 ml of hydrogen gas to give 2 ml of ammonia. 2 ml of ammonia. In terms of molecular weight of the compounds under study, 28 gram of nitrogen reacts with 6 grams of hydrogen. Each hydrogen is having atomic weight of 1. There are 6 hydrogens in 3 moles of hydrogen. So it is 6 grams of hydrogen to give 2 molecules or 2 moles of ammonia, that is 2 into 17 is the molecular weight of ammonia, that is 34 grams. From the example 1 and example 2, it indicates that the relationship between reactants and products of a particular reaction can be studied quantitatively or balanced quantitatively in terms of either moles or molecules or mass and volume. So you can balance any equation, chemical equation or chemical reaction, using either moles, molecules, mass or volume. So in order to balance the equation, in order to have stoichiometric chemical reaction between reactant side and the product side, we need to balance the chemical reaction. For example, if we take the reaction between sulfur dioxide and sulfur hydrogen sulfide or H2S gas, hydrogen sulfide. So this is the reactants which are on the left side. This sulfur dioxide reacts with hydrogen sulfide to give sulfur and water. So in order to, this is the chemical reaction. This is not the balanced chemical reaction. In order to have stoichiometric balanced chemical reaction in this reaction on the left hand side and the right hand side, that is on the reactant side and the product side, we need to balance. So how we can balance? So we are writing the reaction as such. Then we are going to compare the number of atoms of each element on reactant side and the product side. So element sulfur on the left hand side is there is only one, there are two sulfurs. One is in sulfur dioxide and the other sulfur is on hydrogen sulfide. But in the product side, in the given chemical reaction, there is only one sulfur. There is only one sulfur. So in case of hydrogen, in the left hand side, there are two hydrogen in hydrogen sulfide. There are two number of atoms of hydrogen on the left hand side and there are two hydrogens on the right hand side. Whereas if you take oxygen, then there are two atoms of oxygen on the left hand side in sulfur dioxide. There are only one atom of oxygen in water molecule on the right hand side or on product side. So you have two atoms of sulfur on left hand side, one atom on right hand side, two atoms of hydrogen on left hand side, two atoms of hydrogen on right hand side, two atoms of oxygen on the left hand side of the above equation, and only one atom of sulfur on the right hand side. So in order to balance now, so you need to have in the balanced chemical reaction, we need to have same number of each type of element on left hand side as well as right hand side. So for example, if you start with oxygen in the above reaction, then there are two atoms in LHS of oxygen and only one atom of oxygen in water on the right hand side. So we need to balance so that both on right hand side and left hand side we need to have same number of oxygen atoms. So in order to equalize the number of oxygen atoms, we cannot add oxygen to water on right hand side. So in order to make two atoms of oxygen on right hand side, we cannot add 2 to the oxygen present in water. If we add this red mark 2, then what happens? The molecule will not be any more water, but it will be changed to a new compound called as hydrogen peroxide. But the reaction is not forming hydrogen peroxide, but the reaction is forming only water. So what we have to do, we need to change the coefficient of the water molecule so that we will have balanced reaction on left hand side and right hand side. So we can only change the coefficient of the complete molecule in order to retain the chemical nature of the given chemical reaction. Thus, in order to balance the number of atoms of oxygen on left hand side with that of right hand side, we can write as sulfur dioxide plus H2S, where we have two atoms of oxygen on left hand side, then sulfur plus 2H2O. This water molecule, there are two water molecules and each water molecule has one oxygen atom. Since there are two water molecules, we have two oxygen atoms. That means the number of oxygen atoms on reactant side is equal to number of oxygen atoms on the product side. So in terms of oxygen, in terms of only oxygen, now the equation is balanced. But the equation is not balanced in terms of sulfur and hydrogen. Now we will try to balance in terms of sulfur and hydrogen. So in the same way, equalize the number of hydrogen atoms as like in step 3. So we have from the previous equation. So after balancing oxygen, the equation is sulfur dioxide plus hydrogen sulfide gives sulfur plus 2H2O. Then in order to equalize the number of hydrogen atoms on left hand side and right hand side of the chemical reaction, we are going to add 2 molecules of hydrogen sulfide. That means coefficient of the molecule instead of 1, if we change to 2, then the number of hydrogens on reactant side will be equal to number of hydrogen on the product side. So you have 4 hydrogens on the reactant side and 4 hydrogens on the product side. So now the equation, the chemical reaction is balanced both in terms of oxygen and hydrogen. Now we need to equalize the number of sulfur atoms. So in order to equalize the number of sulfur atoms, you take the equation which is balanced now with oxygen as well as hydrogen. So you have the equation sulfur dioxide plus 2 hydrogen sulfide giving sulfur plus 2H2O. So here in this reaction, both the number of oxygen atoms as well as hydrogen atoms on left hand side are equal to right hand side. So only sulfur atoms on the left hand side are not equal to product side. So in the left hand side, you have 1 sulfur in sulfur dioxide and 2 sulfur in hydrogen sulfide. Total 3 sulfur are present on the left hand side. Only 1 sulfur is present on the right hand side in the equation. So now we need to balance the equation by putting a coefficient of 3 on the right hand side, where it makes same number of sulfur on the left hand side and same number of sulfur on the hand side. So in this reaction, if you take the overall balanced equation, then sulfur dioxide plus 2H2S gives 3 sulfur plus 2H2O. In this, you have this, if you take sulfur, there are 3 sulfur atoms on the left hand side or reactant side, and there are 3 sulfur atoms on the right hand side or product side. So you are balancing. So like takdinali ಎರಡು ಕಡೆನೂ ಹೆಂಗೆ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಬೇಕು, like that we are trying to balance the chemical reaction in terms of each type of elements on left hand side and right hand side. So in the above chemical reaction, in this overall balanced reaction, we have 4 hydrogen atoms on the left hand side and 4 hydrogen atoms on the right hand side. That is 2H2. That is 2 into 2 is 4 hydrogen on the right hand side, and even on the left hand side you have 4 hydrogen. In case of oxygen, the 2 oxygen in sulfur dioxide and 2 OR on the water, that on the right hand side. Now the chemical reaction is balanced, or it is stoichiometric. Stoichiometry is balanced. So you have same number of elements of each type of atoms on left hand side equal to the right hand side. That is called as stoichiometric chemical reaction or balanced chemical reaction. So why we need to do stoichiometric balance? So it provides the stoichiometry or balanced chemical reaction provides quantitative information about the chemical equation, helps in various ways. So the balancing of the chemical reaction helps in various ways. That is to know mass-mass relationship. The mass of, if mass of one of the reactants or products is given, then the mass of other reactant or products can be calculated using the balanced chemical reaction. You can also quantitatively find mass volume relationship. If mass or volume of one of the reactants or products is given, then the volume or mass of others can be calculated. Then it can also be used for volume relationship, where if the volume of one of the reactants or products is given, then you can find volume or the volume of the reactants or products which is not given can be calculated. So either you can use to know mass relationship or mass volume relationship or volume relationship. For example, we take one example. So here is a chemical reaction where some amount of carbon dioxide gas is produced on burning methane gas in excess of air or in presence of air. So the reaction is here, the methane is the reactant and oxygen is the reactant. The methane is undergoing burning in presence of oxygen to give carbon dioxide and water. So you have to balance this chemical reaction. Balance this chemical reaction where after balancing of the chemical reaction, you have 2 moles of oxygen. 2 moles of oxygen reacts with 1 mole of methane. Reacts with 1 mole of methane to give the product as carbon dioxide plus 2 molecules of water. So if you find the number of atoms on left hand side, it will be equal to number of atoms of each element on right hand side. So you have 4 oxygen in the left hand side. You have on the right hand side 2 atoms of oxygen and carbon dioxide and 2 atoms of oxygen and water. Totally 4 oxygen. In the same way, on the left hand side we have only 1 carbon and on the right hand side we have only 1 carbon. You have 4 hydrogen on the left hand side present on methane and you have totally 4 hydrogen atoms in 2 molecules of water. So using this chemical reaction, you need to find what is the carbon dioxide produced when 4 grams of methane is present, burnt in presence of oxygen. So we'll see here the given data is methane. 1 molecule of methane will produce 1 molecule of carbon dioxide, or 1 mole of methane reacts with oxygen to give 1 mole of carbon dioxide. So that is what we have in this balanced chemical reaction. So the molecular weight, 1 mole is nothing but molecular weight of the compound, that is 16 gram of methane. 16 gram of methane gives 44 gram of carbon dioxide. 44 gram of carbon dioxide. And we need to find what is the amount of carbon dioxide formed when 4 gram of methane is burnt. When 4 gram of methane is burnt, then on cross multiplication we have 44, that is 44 divided by 4 will give you 11 grams of carbon dioxide. 11 grams of carbon dioxide. So when you burn 4 grams of methane, it produces 11 grams of carbon dioxide. So next, we'll have one more example. If we have this reaction, the same above reaction, where you have the reaction between oxygen and methane to give carbon dioxide and water vapor. This is the balanced chemical reaction. Now, what we have to do is, this is mass volume relationship. So earlier was mass relationship. When 4 gram of methane is burnt, what is the amount of carbon dioxide formed in terms of gram in the earlier case? Now, when you burn 32 gram of methane, what is the volume of carbon dioxide gas and water vapor produced? So you have this balanced chemical equation. So 1 mole of methane produces 1 mole of carbon dioxide. Then what you have is, when you burn, that is 16 gram of methane, that is 1 mole is nothing but molecular weight of that compound is 16 gram of methane will give the 1 mole of carbon dioxide, that is molecular weight of that compound 44 gram. Carbon dioxide molecular weight is 44 gram. So when you burn 32 gram of methane, then what is the amount of carbon dioxide formed? When you burn 32 gram of methane, what is the amount of carbon dioxide formed? So 44 into 2, that is 44 into 32 divided by 16. Divided by 16 is nothing but, 32 divided by 16 is 2. So 44 into 2 is equal to 88 gram of carbon dioxide is released. When 32 gram of methane is burnt, you will have 88 gram of carbon dioxide. Now we need to convert this 88 gram of carbon dioxide to volume. So they have asked in the question, what is the volume of carbon dioxide gas released or obtained? So 1 mole of the substance is nothing but 22.4 liters of volume of gas. So 1 mole of carbon dioxide is 44 grams of carbon dioxide is equivalent to 22.4 liters of the volume. So now we are converting the moles into volume. Moles into volume or grams into volume. So 2 into this 2 is this 2 moles into molecular weight 44, that is 1 mole of the substance is nothing but 22.4 liters. So when you burn 32 grams of methane, it produces 44.8 liters of carbon dioxide. 44.8 liters of carbon dioxide. In the same way, the water vapor produced is calculated. So in the reaction, 1 mole of methane produces 2 moles of water, vapor. That is 2 moles of water vapor is nothing but 1 mole of water vapor is nothing but 18 grams of water. Then 2 moles is nothing but 2 into 18 is 36 grams. Whereas 32 grams of methane is burnt, then it will give you how many liters of water vapor. So 1 mole of water vapor is nothing but 22.4 liters of vapor in volume. So 2 moles of water vapor produced for each molecule of methane are 16 gram of methane, that is 44.8 liters is produced for 16 gram of methane. Then you have 32 gram of methane in the sample, or you are burning 32 gram of methane. For 32 gram of methane, you will have 2 into 2 moles of water molecule produced. 2 moles, means for 1 molecule 2 moles of water vapors are produced. So 2 into 44.8 liters of water vapor. That is, when you burn 32 gram of methane, it produces 89.6 liter of water at standard temperature and pressure. So now what we have done, mass of methane is given. From mass, we are finding the volume of carbon dioxide formed as well as volume of water vapor formed. Then we will go to limiting reagent. So limiting reagent is an important factor which determines the reaction or stoichiometry of the reaction. In a chemical reaction, there are two types of reactants or reagents present. One is the limiting reagent and the other one is excess reagent. So the reactant which is present at lesser quantity and gets completely consumed during the reaction process to form the product is called as limiting reagent. So the limiting reagent is the one which is present in lesser quantity and it gets completely consumed during the chemical reaction to form the product, that is called as limiting reagent. And the reagent which exists in larger quantity than required during the reaction is called as excess reagent. So the difference between limiting reagent and the excess reagent are as follows. So limiting reagent is completely consumed during the reaction, whereas excess reagent is not completely consumed during the reaction. So no limiting reagent, the limiting reagent with the reagent is not present. It is not present at the end of the reaction. So no limiting, the reagent which is considered as limiting reagent, it will not be present after the completion of the reaction or after the formation of the product. Whereas if you take excess reagent, then it is the excess reagent which you have taken that will be left over even after the completion of the reaction. The limiting reagent, it limits the amount of final product formed based on the concentration or amount of the limiting reagent. The product formation will be controlled, whereas in case of excess reagent, you have excess reagent, the product formed will not be dependent on the excess reagent. So there is no effect of the excess reagent on the final product formed. So the reactions in solutions, we take various concentration parameters or concentration terms. Normally, the concentration of the solution can be expressed either in mass percent or weight percent, or it can also be expressed in mole fraction. It can be expressed in molarity, molality, etc. So what is mass percent of the solution? It is the ratio of mass of the solute or element to the total mass of solution. So if you want to obtain mass percent, then the ratio of mass of solute to total mass of solution is multiplied by 100 to get mass percent. Then if you want to calculate the solution sodium chloride, 10 gram of water, what is the mass percent? When you dissolve 4 gram of sodium chloride in 10 gram of water, then the mass of sodium chloride you have taken is 4 gram. The mass of water which you are taking to dissolve sodium chloride is 10 grams. Then mass percent is calculated by mass of solute divided by mass of solute plus mass of solvent into 100, which is equals to 4 is the mass of sodium chloride divided by 4 plus 10, that is mass of sodium chloride plus mass of water into 100, which will give you on simplification a mass percent of 28.57%. 28.57%. So when you dissolve 4 gram of sodium chloride in 10 grams of water, it is equivalent to 28.57 mass percent of sodium chloride in water. Then mole fraction. Mole fraction, it is the ratio of number of moles of solute or solvent to the total moles of solution. So mole fraction is represented as X. X of solute is equal to number of moles of solute divided by total number of moles of solution, which is equal to number of moles of solute plus number of moles of solvent. Or mole fraction of solute is solvent is given by number of moles of solvent divided by total number of moles of solution. So mole fraction is the ratio of number of moles of solute or solvent to the total moles in the solution. So the concentration can also be expressed. So the reactions in solution where concentration can also be expressed as molarity. Molarity. So molarity is defined as number of moles of solute present in 1 liter of solution. Total number of solute moles of total number of moles of solute present in 1 liter of solution. So it is the ratio of number of moles of solute divided by volume of the solution in liters. Whereas the concentration also can be expressed instead of molarity, mass percent or mole fraction in terms of molality. So molality is defined as the number of moles of solute in terms of or in 1 kg of solvent. Molarity is in 1 liter of solution, whereas molality is 1 kg of solvent. So the volume in terms of liter in case of molarity, whereas the volume is expressed, solvent is expressed in kg in case of molality. Number of moles of solute per mass of solvent in kg will give you molality of the solution or concentration of the solution in terms of molality. So this is how you can calculate the molarity of 125 ml of solution containing 0.05 moles of hydrochloric acid. So this 125 ml of solution is converted into liters first because in molarity we are expressing moles of solute divided by volume in terms of liter. So 125 ml is converted into liters by dividing 125 ml by 1000. It gives you 0.125 liters. Then molarity is number of moles of solute, that is HCl 0.05 moles divided by 0.125 liter of solution. So then the molarity of the solution becomes 0.40 mole per liter. So mole per liter is the unit for molarity, and the molarity of the solution is 0.40. So this is about the brief lecture about stoichiometry. So about this stoichiometry, I have sent 2 questions to KSTA, and you need to submit the answers that is balancing of the chemical equation, and the mass to mass relationship. What is the carbon dioxide produced on burning methane? Those two questions have been given. You need to submit those two questions, answer of the two questions to KSTA and get rewarded accordingly. Thank you.
Okay, thank you, sir. Hello.
Hello, thank you, Godro.
Sir, it's an immense pleasure to thank Dr. Lokesh, sir, Professor, Department of Chemistry, Vijayanagara in Krishnadevaraya University, Bellary, for this wonderful speech on stoichiochemistry. This talk has given many information for the students. I greatly thank you, sir.
Thank you, sir.
From KSTA and also personally, sir.
Thank you, sir.
I also thank our CEO, sir, Dr. Ramesh, sir, for this encouragement to organize this talent search program. I am gratefully thank you, sir. I also thank our colleagues, technicians, and the staff members, and our senior scientific officer, Dr. Hanam, sir, and scientific officer, Shiva, sir, their participation to conduct this program. I also thank our chairman, sir, Ayapan, sir, for this participation in this program. Once I thank you each and everyone for their participation. Thank you, sir.
Thank you, sir. Thank you.
Thank you all.